Hi, Mr. T here. In this video we're going to look at force diagrams. In particular, I want you to be able to see what forces to include and how to draw them. And by the end of this, you're going to be able to use force diagrams to explain the motion of objects. Okay, so here is a force diagram. Here's an elephant running along, and it's got 4 force arrows drawn on it. Now, any object in our universe has forces acting on it. It might not always be 4, it might be less, it might be more, but all objects have forces acting on them. Now, forces influence the motion of objects. That means they'll influence the speed, the acceleration, the deceleration of an object. So a force can push, pull, or twist objects. All forces have their specific direction they act in and the size or the magnitude. So this force on the right is acting towards the right, and we can see by the length of the arrow that it is bigger than the force that is acting towards the left. Now, all the forces we're going to draw in our force diagrams originate from the center of mass of an object. Now, the center of mass is an imaginary point in an object that if you were to take that object, you could balance the object by, if you say place them on a stick right at that point, they would balance perfectly. That's their center of mass. Now, our forces usually have labels to say the type of force that they are, and here's 4 types of forces: support, a thrust, a friction, and a weight force. So as I said, the size and the direction of a force is represented by an arrow, with the point of the arrow showing the direction it is going and the length of the arrow showing its size. Now, forces can be broken into 2 subsets. One, forces that occur when objects touch, they are called contact forces, and forces that occur when objects don't touch, they are non-contact forces. Now, a weight force, or the force of gravity, is an example of a non-contact force. Other examples of non-contact forces where objects don't have to touch are magnetic forces and electric forces. The physical quantity force has the symbol F, and the standard international unit, or the SI unit for it, is the Newton, or capital N. So that's kind of an overview of forces. Let's look at some specific objects or some specific forces. There are 5 forces that we really need to know in this topic at this level. The first one is a thrust force. Now, this is a motor force, or a force produced by a motor or by muscles that pushes an object in a certain direction, usually forward, and usually it's what we represent as the force that propels objects in the forward direction. We have a support force. Now, this is a force that comes directly perpendicular from a surface. So usually the surface we're talking about here, and at level 1, that'll be just almost always it'll be the ground, or something that is horizontal with the ground. So the force is always acting straight upwards from the ground at 90 degrees perpendicular, and it's usually opposing a gravity force or the weight force. A lift force is also another force that opposes or goes against the gravity force, but it is produced by the wings of aeroplanes and helicopters and birds, and it's a force that we don't necessarily have to remember, but we might recognize it when it's labeled. 2 other forces I want to go into more detail. One is the weight force. So let's talk about the weight force. People often get confused between weight and mass. Mass is the physical quantity that is measured in kilograms, and it measures how much matter, how many particles, how much of stuff is in the object we're talking about. So don't get confused when someone says, "What is your weight?" They're using the wrong word there. They should be asking, "What is your mass?" Because you always go back and say, "Well, my mass is 80 kilograms or something like that." So the weight is actually the size of the force produced when gravity acts on your mass. Okay, so weight is the force produced when gravity acts on your mass. It so happens that it is always downwards, because when we're on Earth, the object that has the most gravity and is pulling at us is the Earth, and we're getting pulled directly towards the center of the Earth, which is perpendicularly down, or at 90 degrees to the surface. Now, the size of that force is always 10 times larger the size of our mass. So the gravity constant, which is called G, is 10 meters per second. That means that anything that has the gravity acting on it will accelerate at 10 meters per second if there was no other force acting against it. So we have this gravity constant acting on us that produces a weight force, but it's 10 times. What that means is we can work out the weight force of an object by taking its mass and multiplying it by 10. So this 80 kilogram person on the scooter actually has a weight force of 800 newtons. A 50 kilogram student would have a weight force of 500 newtons. A 1,000 kilogram car would have a weight force of 10,000 newtons. So to get the weight force from the mass, we multiply by 10 and we change the unit from kilogram to newton. The next, or the last type of force that we have is a friction force. Now, a friction force always acts opposite to the direction that an object is traveling. This scooter is traveling to the left into the air, and as it goes through the air, to the left, through the air, as it goes through the air, the actual person hits particles of gas in the air as they travel through the air. These particles of gas will rub against the person and cause friction, and they'll change the energy that the person has on the scooter, the kinetic energy, into heat energy. So in order to reduce the size of the friction, well, the first thing we need to remember here is that the friction force will slow an object down. It always acts in the opposite direction to your traveling. And the friction force is caused when an object rubs against other things. It rubs against the air, it rubs against water, it rubs against solid objects. We can make the friction force smaller by making ourselves more aerodynamic. If we were riding a bicycle, we can lean over the handlebars to reduce the surface area that's coming in contact with the air as we travel through it, and that will make us more aerodynamic, and therefore there will be less friction force and we will end up being able to go faster. We can also reduce the friction that might be happening in the wheels. As the wheels turn around and they rub on the axles, we can put oil in there and we can reduce that rubbing of the one solid against another by using a lubricant like oil. We can put oil on the ground to reduce friction force. However, if you reduce the friction force on the ground by putting oil on it, people will no longer be able to put their feet down and push themselves forwards. And when they try and push themselves forwards, their feet will go backwards instead and they will slip over. So be careful about putting lubricant on the ground. Explaining force diagrams. Okay, so let's look at some force diagrams. And here's the first one here. Here's a bird sitting on a branch. The bird, like all objects, will have a weight force acting on it, caused by gravity, acting through its center of mass directly downwards. Because the bird is sitting stationary, it has an equal and opposite force from the branch pushing upwards, called the support force. Now, the weight and the support force are equal and opposite. Because of that, they are balanced. And because of that, there is no overall force. They cancel out. Because there is a net force of 0, the bird is not accelerating, and so it is moving at a constant speed. Now in this case, the constant speed that the bird is moving at is 0 meters per second. However, what we need to remember here is that The reason the bird is moving at a constant speed is because it is not accelerating. And it's not accelerating because its forces are balanced, and its forces are balanced because they're equal and opposite. Let's have a look at this person on the scooter. Their support force and their weight force are equal and opposite. Therefore, they are balanced. Their thrust force and their friction force are equal and opposite, so they balance out as well. In this case, the vertical forces are equal and opposite. The horizontal forces, the thrust and friction, are equal and opposite. They balance out, so the net force is 0. There is no unbalanced force. Therefore, the scooter is not accelerating, and it is also traveling at a constant speed. However, its constant speed is 5 meters per second. So notice this: when you have balanced forces, you must be traveling at a constant speed because you are not accelerating. However, your constant speed can either be stationary or it can be any constant speed. You could be traveling at 5 meters per second. You could be traveling at 5,000 meters per second. It doesn't matter. All that matters is if your forces are balanced, you will keep going at the speed that you are traveling at. Now, this is actually Newton's first law, that an object in motion or an object going at a certain speed will stay in motion unless it has an unbalanced force acting on it, or a net force that isn't 0. So let's look at some net forces that aren't 0, some unbalanced. Here's a bird. It's flying through the air forwards, and it's put its wings up to slow it down. So now it has a friction force going to the right. The weight and the lift forces on this bird are equal and opposite, but there is an unbalanced friction force, and it will cause a net force to act to the right. This net force will cause it to accelerate. Because it is accelerating in the opposite direction that it is moving, it is called deceleration. So the bird will slow down or decelerate because it has an unbalanced force acting in the opposite direction that it is moving. So let's talk about this again. The net force in this case is acting towards the right. Because the net force is in the opposite direction to which the bird is moving, it will cause it to slow down, and because it's it will cause it to accelerate to the right, which will cause it to slow down. So here's another bird here. This bird here is flapping its wings very fast, and it's now got a thrust force bigger than the friction force, though the lift and the weight force are the same. So it's not going to be accelerating upwards or downwards. So the weight and lift forces are equal and opposite. Notice I always use that term equal and opposite. We can't just say that they're equal and cancel out. You need to say they're equal and opposite if you're talking about them cancelling out. The thrust force is larger than the friction force. So because the thrust force is larger than the friction force, it is unbalanced. So there is a net force to the left. This will cause the bird to accelerate to the left, causing it to speed up because it was already going to the left. So we always want to give our explanations in full. We want to talk about how the forces are related to each other. We talk about the vertical or the up and down forces, the horizontal forces. We identify if there is a net force or the net force is 0. Remember, if the net force is 0, there is no acceleration and we're constant speed. If the net force is not 0, then we will accelerate in the direction of that net force. If the direction we're accelerating in is the same direction we're moving, we will speed up. If the direction we're accelerating is the opposite direction we're moving, we will slow down. So this is majority of the time we will just be drawing force diagrams and explaining them. However, sometimes we might need to. So we'll just go over this before we finish the video. So here's a truck, and on the truck I've labeled the magnitude or the size of all the forces that are acting on the truck. So you can see the upwards force and the downwards force of 30,000 newtons are equal. but the forwards force of 6,000 newtons is larger than the backwards force of 3,000 newtons, or the force to the left. Now, the weight and the support force are equal and opposite, so they cancel out. The thrust force is 3,000 newtons larger than the friction force. They are unbalanced. It produces a net force of 3,000 to the left. So if we take away the 3,000 on the right from the 6,000 on the left, we're left with 3,000 to the left. The truck will accelerate towards the left. That's assuming that it was traveling to the left in the first place. Here's another example. Here's a skydiver. They're falling through the air. They have a downwards force, and this must be due to gravity, of 800 newtons. Now, if we just think about this, 800 newtons, remember the weight force is always 10 times bigger than the mass. This person must have a mass of 80 kilograms. Anyway, that's not important for this question. There are 800 newtons pulling downwards, but there is a force of 400 newtons going upwards. This is not a support force. It must be a friction force. There is no surface supporting them. And as they fall through the air, we can imagine that they're going to have the wind blowing against them. And these particles will be rubbing and slowing them down. So we've got this friction force. We can work out the unbalanced or the net force. It is 400 downwards. This means the skydiver will be accelerating downwards. And that is how we work out these videos. If you found the video here useful, check out the other ones that I have on my channel. To do that, subscribe or share these. Don't forget to like, and good luck with answering the questions.